This is how Delhi looks during winters, when the pollution levels are hazardous. Imagine the quality of air people breathe there. Yes, it is toxic. 91% of the world's population lives in areas where air pollution exceeds safety limits. About 560 miles away from Delhi, this is how the ambient environment of an academic campus looks like: serene and fresh. But do you think all the campus residents breathe the same air? Research has focused on monitoring ambient air pollution, but individual exposure to air pollution is not equal to ambient and is therefore important to measure. Our work in progress measures individual exposure of different categories of people on an academic campus. We saw that people at construction sites of the campus are exposed to the particulate matter as high as 1000 microgram per meter cube, and on average, the air quality level is 6 times above the World Health Organization's mandated standard. This means that people working at the construction site are at direct risk of major health implications. In a kitchen which caters to food for more than 1000 people, the air quality deteriorates on specific days when the cooking activity starts, irrespective of the installed chimneys in the kitchen. Is it true that cooking of some specific item causes high pollution than others? Cooks who spend almost the entire day in the kitchen are exposed to the particulate matter as high as 400 microgram per meter cube. Here, on average, the air quality level is at least 4 times above the World Health Organization's mandated standard. Clearly, ambient pollution is not correlated to the exposure level of air pollution. An air quality sensor was placed on a bus for 2 days to monitor the pollution exposure of individuals during transit. The bus travels to and from the campus. With some back-of-the-envelope calculations, we find that even a 2-hour commute involving high exposure could increase even the daily mean exposure by about 8%. We plan to do a more exhaustive study and reduce the form factor and energy need of our sensors to scale the study. We have developed our prototype of the wearable air quality sensor that measures particulate matter, carbon dioxide, volatile organic compounds, beside temperature and humidity. Our next step is to address the challenge of the energy need of the device.